Hello everyone, welcome to another session in the machine learning series. So today we'll continue with our discussion on clustering. So in the previous session, what we basically discussed is what is clustering and what are the properties of clustering, and also its use cases as well, right? So today we look at one particular type of clustering which is called as k-means clustering. It comes under the category of non-hierarchical clustering. Okay, so basically what does k means? In k, what does k basically denotes the number of clusters, and that's why it's called k means clustering. So k means clustering, essentially the idea remains the same, right? You basically have groups of similar objects. So objects in general could refer to anything, right? What we look at is how do you basically create those groups of similar objects, right? Consider an example of a tabular data, right? Consider retail sales data, for example. You're just given a bunch of retail sales data and you're supposed to group them, right? So what we'll basically discuss now is how do you basically group them, correct? So for grouping them, the first thing would be you should be able to measure if two particular objects are similar or not, right? You basically need a measure. You would want a sort of a numerical measure or a way to get that numerical number, right? A measure through which you'll get that numerical number, which will tell you if these particular objects are similar or not similar. So this is one of the say quantitative ways of saying these two objects are similar. Obviously, definitely there could be other ways, but quantitatively assessing whether these two particular objects are similar or not similar is sort of one of the easiest ways to say. It's the easiest way to say the similarity exists between these two objects. So what initially we'll discuss is we'll initially discuss different measures which will help us in saying whether these objects are similar or not similar. Okay. The first similar is something which is called as cosine similarity. Right. Say if D1 and D2, if D1 and D2 are two vectors, right? Cosine similarity of two vectors, the mathematical formula for that is the D1 dot product of D1 and D2 divided by the absolute values. So let's take a look at an example through which you'll get to know that. Say this is an example, right? So D1, this is a vector with this, and D2 is a vector with basically this number. So dot product, right? Very easy to think of dot product is nothing but a mathematical product. Right? So the mathematical multiplication, the traditional mathematical multiplication, right? Row, so you do first row, first column, that kind of thing, right? So that is what this is. That's why you're taking one, so 1:1, say 3 into 1, 2 into 2. Right? This is dot product. For the absolute value, what you basically do is you just square up each value, add them up, and take the root. Right? Doing so for D1 will give you this 6.48, and similarly doing for D2 will give you this. So cost product is nothing but D1 dot product of D1 and D2 divided by their absolute values. Right, so dot product of D1 and dot product of D2 divided by absolute value of D1 and absolute value of D2. Right? So this is cosine similarity. So this is one of the measures through which we can basically calculate similarity. We'll look at other measures in the other sessions.